Stop retraining every new AI agent. This free tool gives your team shared memory, so agents remember your code, docs, and decisions permanently. AI agents suffer from amnesia. Every new session starts from scratch, explaining context, feeding documents, repeating past mistakes. TencentDB-Agent-Memory solves this with an open-source team memory hub that turns conversations, documents, and source code into persistent reusable assets. Built in TypeScript with over 14,000 GitHub stars, it processes work into 4 distinct memory types, not just chat logs, but structured, governed experience libraries. The system automatically extracts valuable patterns from work products rather than just storing raw data. This creates a compounding knowledge base that improves with each iteration of agent work, making your team more efficient over time. Installation begins with cloning the repository using the exact command shown on screen. This downloads the complete project, including deployment scripts and all necessary components. You then navigate to the deploy directory and copy the environment file template to create your configuration. Edit this file carefully to add your LLM API keys for both memory and proxy groups. This is crucial for the system to function properly. Finally, run the start all script, which launches all 3 services together: memory core, memory hub, and proxy in a single coordinated operation. After running the start script, the system launches all 3 services automatically and handles the initialization process. When complete, it provides a convenient one-liner you can paste directly into Claude for immediate integration. The dashboard becomes available at localhost port 8125, where you can monitor the system status. Complete installation documentation covers standalone deployments, proxy configurations with Claude Code and CodeBuddy, and detailed troubleshooting steps. For existing users upgrading from older versions, there's a dedicated migration tool to seamlessly bring your historical data to the current release. The core innovation is processing teamwork into 4 reusable memory assets that transform raw conversations, documents, and code into structured, governed experience libraries. Unlike standard RAG systems that just store and retrieve chunks, these assets maintain ownership tracking, version control, and granular access permissions. The system automatically extracts valuable patterns and workflows from completed work products rather than just archiving chat history. This creates a compounding knowledge base that improves with each iteration of agent work, making your team progressively more efficient over time. First up is chat memory, which isn't just a conversation log, but a sophisticated pipeline that distills raw dialogue into layers of understanding. It starts by preserving the complete L0 conversation record with full context and timestamps, then extracts key L1 facts, preferences, and constraints from the discussion. These are then organized into L2 scenarios, knowledge blocks grouped around specific projects or work contexts. Finally, it builds L3 long-term personas and stable patterns that represent high-level cognition about users and teams. Second, skills represent executable experience that agents can extract after successfully completing complex tasks like code reviews or release checklists. These are far more than simple prompt snippets. They're versioned assets with defined execution steps, resource files, trigger boundaries, and validation rules. Skills can be kept private by default or shared with the team after review, and they can be precisely assigned to specific agents who need that capability. This means troubleshooting workflows, architectural patterns, and operational procedures only need to be learned once before the entire team can benefit. Third and fourth are WIKI and CODEGRAPH, which transform your documentation and codebase into structured, searchable knowledge assets. When you point it at your product docs, design specs, and runbooks, it automatically builds a wiki with structured pages and a link graph for easy navigation. For codebases, it creates a code graph that indexes files, symbols, call relationships, and impact paths, not just file lists. This means your agent can search, read relevant pages, inspect caller-callee relationships, and perform impact analysis before modifying any code, preventing costly mistakes. But here's where it gets really powerful. You're not just creating isolated assets, you're building a coordinated team with specialized roles. Remember the promise from the start? This is how your agents truly collaborate, rather than working in silos. You can create distinct roles like a scout for research, a builder for development, and a reviewer for quality assurance. Each role gets equipped with only the specific memory assets it needs for its particular job function, preventing context overload and ensuring optimal performance for each specialized task. For example, your builder agent gets equipped with the product wiki for documentation, the project's code graph for understanding code relationships, and feature delivery skills for standardized workflows. The document agent, reviewer agent, receives historical incident memory for context, the project code graph for impact analysis, and release checklist skills for consistent quality assurance. This targeted approach keeps the context highly relevant for each role and prevents overloading agents with unnecessary information. You control these entire loadouts from the central Memory Hub dashboard with precise granularity. You manage all of this from the comprehensive Memory Hub dashboard, which serves as your central control panel for the entire memory ecosystem. Here you can view and manage asset ownership, track version history, monitor usage counts, and see exactly which agents are using which specific assets. The interface allows you to review, approve, and share assets with team members, or keep them strictly private to individual agents based on your governance requirements. This centralized management eliminates the chaos of disconnected agent memories and provides enterprise-grade oversight. Crucially, sharing is always explicit rather than automatic. New memories remain private by default until you deliberately choose to share them. The Hub supports fine-grained access control through multiple visibility levels: private for owner-only access, team for all members, restricted for precise ACL-based permissions, and agent for targeted equipping within the same team. This solves a critical governance problem for real team environments where sensitive information must be protected while still enabling appropriate collaboration between agents and human team members. Under the hood, the system employs intelligent memory processing that works in distinct layers from raw conversation logs up to high-level persona representations. When an agent needs to recall information, it starts with the most efficient L2 per liter 3 summaries for quick context restoration, and only falls back to detailed L1 per liter 0 data when specific facts are required. This layered retrieval approach prevents context window bloat and ensures fast, relevant memory access. The system uses BM25 plus vector retrieval with reciprocal rank fusion to balance precision and recall, capped by item count and character budget limits to maintain optimal performance. The project includes comprehensive benchmark testing to validate its effectiveness in real-world scenarios. Performance metrics demonstrate significant improvement in agent recall accuracy and context application compared to basic conversation logging. These benchmarks specifically measure persona mem performance, testing whether agents can correctly understand and apply user information after extended interactions. The results show a 59% relative improvement, jumping from 48% baseline performance to 76% with TencentDB-Agent-Memory enabled. This proven effectiveness makes it a compelling choice for teams serious about agent productivity. Version 2.0 brings powerful features, but has some current limitations you should know about. WIKI and CODEGRAPH indexing requires asynchronous processing time. Assets aren't immediately available after import. CODEGRAPH currently prioritizes public HTTPS repositories, with private repository and SSH credential support still being refined. The Hub supports manual asset binding and equipping, but fully automated memory routing is still under active iteration and development. These are honest trade-offs for a rapidly evolving open-source project. Essential for teams running multiple AI agents that need to share context and avoid repetitive work. Overkill for one-off tasks or single-agent setups where basic conversation history suffices. Adds crucial governance and structure missing from standard RAG systems, making it ideal for production environments. Currently supports OpenClaw, Hermes, Claude Code, and CodeBuddy, with broader framework support on the roadmap. The free open source model makes it accessible for experimentation before committing to enterprise deployment. Clone, configure, run, get permanent shared agent memory, free and open source.